Okay, let's concentrate on the drill shaft log, the drill shaft excavation log. This section contains special block when you input the details of the casings. You have one side here, you got something called outside casing, then you have here the inside casing. Okay, typically for miscellaneous structures, you will not have to worry about two casings most of the times, or I never seen a miscellaneous structure with two casings. So this should be okay with just one casing. For miscellaneous structures, you will input the information of the casing here. I'd rather do it here. If you input it here, that's fine. That's fine. You know, it doesn't. I think in general it's okay, but you know, but just to keep in line with what we've been using, and we're going to be using on bridges. You know, I'd rather use it here. Now, let's take the opportunity. Let's talk for both cases, and not just for miscellaneous, but also for bridges. Typically in bridges you do have, like this sketch here, you may have a situation where you have two cases, particularly if the plans call for a permanent casing. There are some projects when the contractor may decide to leave a permanent casing outside, a little bigger than what is required in the plans, and then use the internal casing with the minimum dimensions required by the shaft, which he can use in a temporary support basis. So, you know, this could, it's a typical case situation, but in any case, you have two casings, what we call the outside casing, 2 is here, and inside casing is number 1 here, right? So that's what we meant by this one, as that's what we meant by C casing illustration, just to basically remember what to use as a casing 1 and 2. I repeat, in miscellaneous structure, really is not it doesn't have consequence whether you use it here or here, but I'd rather everybody, for consistency, you put that information here. In bridges, therefore the inside casing will be typically temporary, in a temporary situation. The outside casing could be both, could be the permanent or could be temporary. I have seen in some cases permanent locations for the outside casing, but whatever it is, you can input whether, you know, this is nothing that is fixed. You can input whatever is being used anyway. Now, typically I have seen projects, and that's why we created this form this way, when the contractor uses several segments or sections. For example, he may, in bridges, for example, he may decide to input the first section 30 feet. He starts with 30 feet. Let's start with this example when I have like a reference elevation of 20, so which means the top of the casing. Remember that the top of the casing is typically our reference elevation, unless we indicate something else. So in this particular case, this would be 20. Okay. So let us assume this case. You got a 60 inches in ID casing, which is 5 feet. 61 inches outside diameter. That's basically a 0.5 inches thickness of the casing that we need to input. By the way, you can input here 0.5, whatever it is, 3/8, 0.375, or whatever it is. But you know, in this particular case, to make it easy, it's 0.5. So that's going to tell us a difference in the diameter of 1 inch. Okay. So let us assume in this case, as you have the top of the casing is 20. So if I use only one casing, which is 30 feet in length, the spreadsheet is going to compute a total length of the casing of 30, because it's only one, 30, 30. The top elevation of this section will be 20, same thing. Then the lowest of this section will be minus 10, because you got 20 minus 30 is minus 10, so it's the same thing. So in this particular case, we only have one section here. Let's say the contractor needed to do more. So 30 feet, and then he added, say, 20 feet more. So if I added 20 feet more, what happens is the total length of the casing now is 50, correct? So 20 minus 50 gives you 30. And the individual sections will be, okay, now in this particular case, this would be the second lowest section would be 20 minus 20, 0. And this, my original casing was moved down, right? So now the top elevation of that casing, of that section would be 0, minus the 30 length will give you minus 30. So it will give you the bottom and top of each section, plus it will compute the total length of the casing on the bottom of the final of the total casing. Well, let's say this is a very long casing and or a very long shaft. He keeps adding stuff. He puts another 20 feet. So which means now we're gonna have a 70, right? Let's see. If I enter that thing, I'm gonna have 70 feet total length of casing. My reference elevation originally was 20. If, let's say I keep, or it may change, by the way. Very likely this reference elevation will change because the reference elevation will be now my third casing, which could be maybe 25. Once I input the 25, this 25 becomes, that's the top of the final section. So which means 25 minus 20 is 5, and this 5 of the third section becomes the top of the second casing I have placed before. 5 minus 20, that's minus 15. This becomes the top of the casing here on my very first section I put, and that's minus 15, minus 30 is minus 45. So everything keeps working out. Let's say I put another 15 feet. So let's say I put another 15 feet, and now my top elevation of that casing was 30 feet. So the top of that casing will end up in 30 feet, right? Minus 15 feet ends up in the bottom of that section of 15 feet, and then that 15 is the top here, minus 20 is the minus 5 here, and so forth. Now let's add another one, let's say I added another section which is maybe another 30 feet, and then maybe the top of the casing at that point, it went all the way to 15 feet. The top of that casing is 15 feet. Now my reference is 15 feet. So I ended with a total length of 115 feet. I'm here, okay? So see, basically I use the full capacity of the spreadsheet. I'm using 5 sections. So this is the thing that I input first. Now it becomes the lowest section. This is, so in other words, this is this portion here. Then as I keep adding, this becomes the second lowest section. As I keep adding, this becomes the third lowest section. This becomes the fourth lowest section here, and this becomes the fifth lowest section, so which is the top section. Okay, and you can verify that the length, the summation of this one gives me the total length of this casing, the assemble of the 5 sections. Then the top would be here. This would be 15, and this one would be minus 100. Yeah, which is 15 minus 115, and this data here is are giving me the individual bottom elevations. Okay, for example, here this would be 15 here, this would be minus 15 here, and so forth. Okay.